Today we are going over Chapter 9, Section 9.1, which is about simple events. Chapter 9 we are going to talk about probability, which is going to be one of the key things we cover over the whole chapter. So for vocabulary, first vocabulary we're going to go over is outcome. And that is any one of the possible results of an action, such as flipping a coin. An outcome could be tails, or an outcome could be heads. A simple event is one or a collection of outcomes, meaning the act of flipping a coin would be the simple event. The tails or heads would be any of the two outcomes. Probability is a chance of an event happening. We are typically going to look at this as the number of favorable events over the number of possible events, so kind of like the total. Random is going to be, we've actually covered this previously, is going to be where every event has an equal chance of occurring. Has an equal chance of occurring. So everyone's got an equal shot at it. Lastly, complementary event is kind of the opposite of probability. What it actually is, it's the opposite of an event happening. So it's a chance of an event to not happen. So, probability and the key concept of if all event outcomes are equally likely, or everyone's got an equal chance, the probability of a simple event is a ratio. Again, ratio keywords that compares the number of favorable outcomes to the number of possible outcomes. Again, this is just what I wrote on the other side. The only difference is when we have a P like that, we read that as probability of the event to happen. And whatever's in the parentheses is what we would read. Probability that tails would land would be P parentheses tails. Below we see here that we have a chart ranging from 0 to 1 or even 100. Now this is showing us that probability can be written as a fraction. As you see, the top line are our fractions. It can be written also as a decimal and as well as a percent. So we have several different ways that we can write probability. Throughout this chapter we're mainly going to focus on writing it as a fraction. However, it's good to know, using our other styles, how to turn that fraction into a decimal or turn that fraction into a percent. First example we will do is a single die or a number cube has sides numbering 1, 2, 3, 4, 5, and 6. What is the probability of rolling a 2? So we're looking at P2. Well, if there are 6 sides on a die, I only see one side that has a 2. Otherwise we have 1, 2, 3, 4, 5, 6 are all our possible outcomes. We would actually count these up, and that's 6 outcomes, 6 sides on a die. Over here we only have one way of rolling a 2. So we have 1 over 6, and our probability is 1/6. If we wanted to put this as a percent, a 1 divided by 6 would give us our decimal form of 0.16 with the 6 repeating. And as a percent, we move our decimal 2 to the right, and we get 16 2/3%, because that 6 would keep repeating. So those are the 3 different forms right there. Writing the probability of the fraction in simplest form, what is the probability of rolling an even number with the same number cube? So probability of an even number is going to give us, again, we'll have all 6 options on the bottom. And again, counting these, we have 6. But for even numbers, I see we have 2, 4, and 6. So if we put 2, 4, and 6 up here, that's 3 total ways of rolling an even number. So that leaves us with 3/6. Now, we aren't done yet, as it's not in simplest form. We can simplify this. Both of the top and the bottom are divisible by 3, which will get us simplified into 1/2. It did ask for a fraction in simplest form this time, so we'll leave it at 1/2 and not show the other 2 forms. Jane has a deck of cards that are numbered 1 through 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. A card is picked at random. write the following probabilities as a fraction in simplest form. So this is read the probability of drawing 5. We only have one 5 in our deck. So we have 1, and there's 10 total cards, so number possible is going to be 10. Remember, we're thinking about this as number favorable over number possible. So we only have 10 possible ways, so that's our denominator, and we have one possible way, being favorable way, of picking that 5. So our answer is 1/10. Continuing on, what is the probability of picking an odd number? So odd numbers 1 through 10 are going to be 1, 3, 5, 7, and 9, and that is 5 total numbers that are favorable. We already know up here that we have 10 total possible ways, so we know our denominator is going to be 10. 5/10 again isn't simplified. We divide both the top and bottom by 5 to get 1 on top, 2 on bottom, which is also known as 1/2. Lastly, we have the probability of a multiple of 4. Thinking, what are our multiples of 4? Multiples would be 4, 8, 12, 16. However, we only have cards counting up to 10. So we have 4 and 8, and again we're going to have 10 already done on the bottom. 4 and 8 are only 2 cards, so we have 2/10 is our answer. Again, both top and bottom are divisible by 2 this time. So we can simplify this into 1/5, and that is our answer. On to complementary events. So complementary events are solved in a slightly different way. So using the same 10-card deck from the last example, what is the probability of not picking a 5 or 10? So probability not 5 or 10. Now this is kind of hitting on two things at once. So we're going to go one at a time. We're going to go probability of not, right? So probability of not hitting a 5 or a 10, meaning the probability that we'll draw one of those other cards. So the idea is we're going to take 1 being our 100% and subtract the probability of getting a 5 or a 10. So that way we're going to take every card, all 10 of them, and then take away the option of grabbing those 2, and so we'll be left with the 8 options of not grabbing those 2. So this 1 minus the probability of 5 or 10, probability of 5 or 10 is going to be 2 over 10, and we don't need to simplify that yet because we'll simplify in the end. Now our 1, we can't subtract 2/10 from 1 without having the same denominator. So we're going to change our 1 into 10/10. So 10/10 is another way of writing 1, because that's our total number of cards over our number of total possible, right? 10 over 10. So subtracting 2, we're just going to subtract the numerators across the top. 10 minus 2 will give us 8 over 10th, and now we can simplify to get 4/5. Probability of not a prime number. So what are our prime numbers? It's kind of good to go over definition. Prime numbers, 1 through 10, are going to be 2, 3, 5, 7, right? And what do those numbers have in common? These are all numbers whose only factors are 1 and themselves. So 2 is 1 times 2. 3's only factors are 1 times 3. 5 is 1 times 5. And 7 is 1 times 7. So if these are all our prime numbers, we already know our total possible is going to be 10 still, right? 10 cards. So taking away those 4, again, we got to remember we're taking 1 minus those 4/10. We're going to have to rewrite this as 10/10 minus 4/10. 10 minus 4 will leave us with 6/10. And we then have to simplify by dividing both by 2 on the top and bottom to get 3/5. Lastly, probability that's not a multiple of 3. Again, our setup is 1 minus probability that is a multiple of 3. So, probability that it's a multiple of 3. We have 3, 6, 9, 12. 12 is not going to be included because that's above 10. So we have 3 out of the 10 cards we're taking away. We now already know we've got our 1 here. We can turn that into 10 tenths, because that's another way to creatively write 1. So now we are pretty much all set. We have 10 cards total, and we're taking away those multiple of 3, the 3, the 6, the 9, to have the 7 cards remaining out of the 10 total. So our answer is 7 tenths. Lastly here is we're using a table. This is going to be similar to a homework problem side. The table shows the students who attended a school dance and were entered into a raffle drawing. Suppose that only one student is selected to win. Randomly drawn, right? It's a raffle. So find the probability of each event and write it as a fraction in simplest form. So probability that not an 8th grader wins. So one thing I'm going to point out about the chart first is that it's split in two. This bottom half and this top half are both going to equal the same amount of numbers. Our 120 plus 105 students gives us 225 total students, can be split up into 2 ways. We can split them up between boys and girls, as we have 120 girls and 105 boys, or we can split them up by grades. We have 131 7th graders and 94 8th graders. Both will add up to 225. So when we're looking at probability of not an 8th grader, we look and we see if they're not an 8th grader, they're going to be a 7th grader. So we're going to have 131 favorable over our total possible of 225. To simplify this, we would need to use a calculator. We won't need to use a calculator, but we could use a calculator and use our ABC button on our TI calculators. However, 225 is going to be only a factors of 5 here. So 225 is actually 75 times 3. So it's going to break down again into 25 times 3. So right now, doing our factor tree quickly, we have 5 squared times 3 squared. So it leaves us with 2 quick ways. 131 does not end in a 5 or a 0, so it's not divisible by 5. 1 plus 3 plus 1 adds up to 5, so it's not divisible by 3. So 131 over 225 is our simplified form. That is our answer. Now, looking at our last question, we have probability that it is a girl. So we see that we have 120 girls, and we already did our total of 120 plus 105 to get 225. So we just need to write 120 over 225. They're both divisible by 5 here. So, dividing both by 5, we're going to get 24 on top. And we're going to get 45 on the bottom here. So, 24 is divisible by 3, as is 45. So we're going to get 8/15. And that's our final answer. If you have any more questions or need to do any more problems, there is homework help available on Moodle. Otherwise, there is also peer tutors that you can watch.